Another advanced question. This one is from Pathfinder. So there is a, I'll just brief you what is the question. There is one glass tube here which contains water, and there is a small air bubble here. Okay. Now we start rotating this with omega. And when you start rotating this with omega, this bubble comes here. Okay. So we need to find, if this length is L, we need to find what is this length where the bubble comes if it is rotated with omega. Okay. Let us move forward. Suppose this is still. Let us see why the air bubble is here. Why not here? Why not here? Like that. From force point of view. We know that if there is an air bubble here and there is water, it will obviously come up. I'll just mention what are the forces. See, the first force is mg, that is gravitation. The second force is mg by s, which is the buoyant force. Now, air has very low specific gravity, so this quantity is very high. Okay, and this quantity is lower compared to this. See, this has component 1 in this direction and another in this direction. We are not interested in the components in this direction. We are interested in the components in this direction. I'll take a component of this in this direction, component of this here. So suppose the bubble was here, mg by s is greater than mg component. So that is why the bubble will go up and it comes here. Why it can't go away? There is a container blocking it and it can't go away. Okay. What happens when we start rotating it? As we start rotating it, there are two forces. The first is the buoyant force. See, suppose this is a body. It is in circular motion. If it is in circular motion, its acceleration is in which direction? Towards the center of the circle, right? That means if this is a container, the acceleration of the container at this instant is towards this direction. If the acceleration is in this direction, the buoyant force will be in which direction? In this direction. Okay. So what will be the buoyant force here? V into rho into A. So acceleration, if this is some L, this will be L omega square in this direction. Okay. So let us just write ma by s will be the buoyant force in this direction. Okay. And there will also be a pseudo force. The pseudo force will be m into a in this direction. We have already seen that s is very small, so this quantity is very large. So if you take a component of this here, there is an unbalanced force. That is why this starts coming in this direction. Okay. Let me show you a small animation of this. So you see, as it is being rotated, what happens? These two vectors remain constant, and you see the other vectors. So this is we are in a rotating frame right now. Okay, you see this cube rotating. So we are in a rotating frame. There is one buoyancy force and the pseudo force. Because of motion of this, there is also a Coriolis force. But Coriolis force is in perpendicular to this, so we don't require that Coriolis force now. But as of now, these are the forces which we require. Okay. So now, suppose the body, finally comes here. And here it is in equilibrium. What are all the forces? Tell me. This is, if this is some angle theta, so this will be mg cos theta. This will be mg by s cos theta. It would have been like this, mg by s cos theta. This force, suppose it has come here, what will be this force? Tell me. M Okay. Acceleration. What is the acceleration? R omega square. So I'll write this as some x omega square, okay, by s. Pseudo force, mass into acceleration, that is m x into omega square. Okay. This, the body is here. So we can now balance all the forces, right? So if I balance all the forces, this is 90 minus theta, and this is also 90 minus theta. If I just balance all the forces, what will I get? Just a minute. Mg cos theta plus mx omega square by s sin theta equal to plus mx omega square sin theta. Mx omega square sin theta. It is in equilibrium. So we are balancing all the forces in this direction. See, what does this x tell me? This x is this, okay? And if this is eta, he has given this as eta L from here to here, okay? So if this is eta L, this x will be eta L sin theta. So I can just write this as eta L omega square sin square theta. So this eta is what he is asking. What is the fraction of length where it comes to equilibrium? So eta comes out to be g cos theta by L omega square sin square theta. Okay, all of you. So now we can proceed with the advanced MCQs.